So hi, my name is Carrie Moore. I will be going over this assignment. And basically for the statement, or what we have to do is create or finish creating this sequential search algorithm where we are comparing values in search of a key and demonstrating the worst case scenario. So basically for our algorithm, a sequential search is essentially when you start at the beginning of a data set, compare values in search of a key, which is a value you are searching for. And this comparison continues until it reaches the end of the data set. And depending on if you find the key or not, and when you find it, will result in three case scenarios. The best case scenario, which is when you find the value at the beginning of the set, which rarely happens. The average case value, which when you find the value in like the middle of the set, and then worst case scenario, which is when you either find the value at the end of the set or don't find it at all. And so for my code, I make sure, and I'll go over it again, to make sure the value wasn't in the data set, just to ensure that it was a worst case scenario. So now for the code, at the beginning, of course, you have to start by importing the important libraries that you'll need, such as the GDown, which is used here, which is to download the drive where the data set is located and convert it into a list, which will be used to do the search. And then here, it just pretty much reads the file and then adds it to the list. So this portion right here is actually the sequential search function where it'll define this variable sequential search, call it, and look for, or it'll contain data and the key, which will be used to compare the data to the key. We keep track of the variable comparisons to make sure that we set it to 0 to make sure it starts at the beginning of the data set. And then we have a loop here to basically just compare the data to the key, increase the comparison so that we go through each value to keep track of how many values we are comparing within the data set. And then if the key is found, aka if the value of the key is equal to the data or equal to a value in the data, then it'll exit the loop and just return the amount of comparisons made. And then if it's not found, then it'll still do that, but it'll just be a worst case scenario and it just won't have the key. So this portion is just like my example where we have the input sizes, which is just a range of starting from this specific range up to 1,000, incrementing by 100. We have this variable here to ensure that we can keep track of the comparisons. And then this portion is just the same as the function, the search function, where it'll search and compare values. And because I have the key set to a value not inside the data set, it again guarantees worst case scenario, and it just won't be found. So that would then be printed here and then plotted, which will look like this, keeping track of the numbers or values in the data set, as well as the comparisons made, and then the plot, the actual algorithm, which X value being the input size, and then Y value being the comparisons. And that's it. Thank you for listening.